Hi, welcome to Solving Science. I always seem to start these videos with saying, hey, today this is a big one, it's an important one. And generally speaking, they all are. But this is a big one. It's time for a new model of the universe, okay? As reported in New Scientist, 10th of May, 2025. And this is the kind of article that really stands out for people thinking about new models and looking at expanse tension theory as a framework. I'm going to just read you what this article, how it starts. Shocking results from a major astronomical study are forcing scientists to consider new ways of understanding dark energy and gravity, in the wake of a bombshell finding that now suggests dark energy might be weakening as the universe expands. And they're now considering replacing the standard model, the standard cosmological model of the universe. Okay. Now let's unpick that. What does it mean? Well, there is a telescope called DESI. It's the Dark Energy Spectroscopic Instrument, and its latest measures suggest that dark energy, this phantom mathematical cheat code in ΛCDM, lambda meaning dark energy, CDM meaning cold dark matter, both mathematical cheats to try and explain what we see. But that lambda, which should be a constant figure, is now weakening. Now that's a pretty big problem. If your theory is based on having a cosmological constant called lambda, and then it changes, because that means it's not a constant anymore. Now, why does this, what is the problem? Let's define what the problem is. So the Standard Model of Cosmology assumes that ordinary matter, dark energy form the universe, and that dark energy drives accelerating expansion of the universe, and it's assumed to be constant over time. These new DESI telescope results, they now hint that acceleration of the universe is weakening, and lambda CMD can't support that. It destabilizes lambda CDM as a theory to explain the universe. And the worst thing is now that, scrambling in the melee and confusion, scientists are now exploring quintessence fields and changing dark energy and modified gravity, adding a fifth force and another unknown fifth force to the universe. And it feels as a problem solver, scrambling to fill and plug gaps without stopping and regrouping and going back to problem definition, as hopefully you will see I've done. Now this is music to my ears for expanse tension theory, because expanse tension theory can explain very clearly why expansion of the universe is changing and will continue to change in ways that a standard mathematical formula of that kind can't justify, can't explain. So what does expanse tension theory say? Well, we have a dynamical density-dependent universe of coupling switches that is coupling mass to expansion depending on density of the given universe. Expanse tension theory explains why late-time acceleration started as a coupling switch to greater coupling, and it took that expansion that drove the expansion. But then there's an inflection point that's coming, and we might now start to be seeing a slowdown that we've seen before. These inflection points, as explained in the previous video, explained why did exponential inflationary phase come to an end? No one can explain that, but expanse tension theory does. Why did late-time acceleration start? And we can explain that with an inflection point. And now, why might it change? And we can also explain that. So, expanse tension theory is the perfect candidate to fill this. We need a new model of the universe. What have we got? In short, the muddle arises because lambda cold dark matter assumes a static dark energy. We now see that assumption fails. We can explain with expanse tension theory the observations very cleanly. It's accelerating or weakening coupling between mass and expansion. And it gives us this explanation without more exotic inventions. We don't need quintessence fields. We don't need to add another fifth force that we haven't seen. We don't need additional terms. We can explain it with what we have, with what we know, with existing quantum field theory, logic. We're not inventing any new physics whatsoever. We have the Higgs field now proven by CERN, and we have the ability of the Higgs field to couple or uncouple to expansion. So, a perfect article for someone looking for a new cosmological model of the universe. What I've also done, I'm now mapping all of the major theories of the universe, like MOND, modified Newtonian dynamics, and there's some lots of others. So I'm now modeling them, and I'm plotting them against the 300 cosmic phenomena that they would each need to explain. Okay, so imagine a huge grid of dozens of theories of the universe and their ability to explain all of the different range of things we see. Expanse tension theory is winning in that grid. Now, it's my analysis going in. I'm studying these phenomena. I'm then taking the paper and I'm putting it into multiple online search tools to clarify, test, check, passing it from one AI to the next, to the next, to the next, as a repeatable, reproducible step in the process. So I know many of you are nervous about what AI can do, and to give myself some quality checks in that, I never use a single AI. I'm usually using 4 or 5, and I check and check and check. So as a Six Sigma Master Black Belt, that's what those certificates are. I have a discipline to do this right, and that's what's happening here. So, time for a new model of the universe. Imagine if it's expanse tension theory. Imagine if it's a density-dependent universe, which is inflecting in these ways that no constant could explain. Okay, thanks for listening, and thanks for following. Bye-bye.